Hello students, welcome back to the fifth video of this playlist. In this video, we will be solving question number 5 from the most recent past paper of Mechanics 2, which is the October 2024 M2 paper. So let's get started with question number 5 of this paper. So here the question number 5 says the fixed points x and y lie on horizontal ground. At time t equals to 0, a particle p is projected from x with speed u meter per second at an angle theta to the ground. Particle p moves freely under gravity and first hits the ground at y. Okay, show that. So part A is asking to show that the distance between x to y, that is xy, equals to u squared sine 2 theta over g. Okay, so let's say this is the horizontal ground. Okay, and this is the point x from where it has been projected. So it will go up and then it will reach the ground again at the point y. Okay, so we have to find out this distance between x to y. So this angle, it is given as theta, and the initial speed, it is just u. Okay, now we know that the distance between x y can be found easily using the distance x y equals to vt, right? The horizontal component of speed, that is u cos theta, right? So u cos theta times t. So where this t is basically the total time of journey of the particle. So we have to figure out this total journey time, okay? And then we can use the horizontal motion of the particle to get the distance between x, y. Okay, so to get the total journey time, we will consider the vertical motion of the particle. Okay, if you consider the vertical motion, so when the particle will reach the ground, look, the particle was projected from this point, and then again vertically it is reaching the same level, right? So that means when it reaches the same level, the displacement would be 0 meter. Okay, so displacement is 0. So for vertical motion, consider the vertical component of velocity, initial velocity. We will use a sine theta for that. So sine theta equals to the vertical component of velocity u vert over the hypotenuse, which is u. So the vertical component of velocity, it is u sine theta. Now consider the formula. S equals to ut plus half of at square, ut plus half of at square. So we are taking upward as positive, okay? The displacement would be 0, s is 0, and vertical component of initial velocity, it is u sine theta. So u sine theta times t. So since upward is positive, so gravity is acting downward, so it will be negative half of g t squared. Okay, now we need to figure out the value for t, the total journey time. So take t common, so you will get u sine theta minus half of gt. This is equals to 0. So either t equals to 0 or u sine theta minus half of g t equals to 0. Okay, so from there we can figure out the total journey time. Okay, if you make t the subject, so multiply both sides by 2 and take the term with t on the right side. So you will get gt equals to twice of u sine theta. Okay, so if you make t the subject, you will get twice of u sine theta over g. Okay, so we got the total journey time t, that is 2u sine theta over g. Now consider the motion of the particle horizontally. So horizontally, we have to consider the horizontal component of initial speed, that is cos theta. We have to relate it using cos theta. Cos theta equals to u horizontal over the hypotenuse. So horizontal component of initial velocity, it is u cos theta. Now horizontally the speed will remain constant because horizontally there are no resultant forces acting on the body. Okay, vertically the speed will not remain constant because vertically there is acceleration due to gravity. Okay, so xy, the distance between x to y, it is equals to vt. So v will be the horizontal component of initial velocity, so u cos theta times the total journey time. The total journey time, it is 2u sin theta over g, because after the time that we got t equals to 2u sin theta over g, this is the time required for the particle to move from x to y. Okay, so there is 2u sin theta over g. So 2u sin theta over g. Now consider what you will get. You will get 2u squared sin theta cos theta over g. So we know that using trigonometric double angle formula, 2 sin theta cos theta is basically cos sin 2 theta. 2 sin theta cos theta can be written as sin 2 theta over g. So xy equals to u squared sin 2 theta over g. And that's what exactly part A of question number 5 has asked to show. Fine. Okay, next is part B. In part B, the question says the points A and B lie on horizontal ground. Okay, a vertical pole CD has length 5 meter. The end C is fixed to the ground between A and B. Okay, where AC equals to 12 meter. The distance from A to C, it is given. You can visualize this scenario in the figure, that is figure number 4, the fourth figure of the question. At time t equals to 0, a particle q is projected from point A with speed 20 meter per second at 60 degree to the ground. Particle q moves freely under gravity, passes over the pole, and first hits the ground at point B as shown in figure 4. Okay, so part B is asking to find the distance between CB. Okay, so the distance between CB. So the distance between AC is given, so we need to find out the distance between C to B. So this is very easily could be figured out using the equation that we have derived in part A. So we know the initial speed, right? We know the initial speed. In this case, it is u equals to 20 meter per second. We know the theta, this is 60 degree, so we can easily find out the distance from A to B using this equation. And if we know the distance from A to B, then we can easily find out the distance of C to B, right? Okay, so let's find out the distance of A to B at first. For part B, AB, distance AB, it is equals to u squared. Initial speed, it is 20 meter per second. So 20 squared times sine 2 theta. Sine 2 theta, theta is 60 degree. So that would be 120 degree over g. This is the distance between A to B. So this is equals to 20 squared. 20 squared is 400. Sine 120 degree, this is half, root 3 over 2 sine 120. So you will get, okay, so 20 squared is 400 times square root of 3 over 2 over g. Keep it in exact form. So you will get 200 square root of 3 over g, that much meter. This is the distance between AB. So the question is asking to find out the distance of CB. So distance of CB would be the distance of AB minus AC. So CB equals to AB minus AC, right? So the distance of AB, it is 200 square root of 3 over G minus the distance of AC, it is given as 12, that much meters. Okay, now just calculate the distance CB. So 200 square root of 3 divided by 9.8 negative 12. So this is basically 23.34797566 meter. That's the distance between C to B. Okay, so we got distance CB up to 3 significant figures. We can write 23.3 meters. That's it. That's the answer for part B from question number 5. Fine. Okay, next is part C. In part C, the question is asking to find the height of the particle Q above D at the instant when Q passes over the pole. Okay, so we need to find out the height of the particle Q over the pole CD as it is passing over the pole. Okay, so for that we have to find out at first, considering the horizontal motion of the particle, that how long it will take to reach the point C from A. Okay, then using that time we will find out the vertical displacement. Okay, and then from the vertical displacement we can figure out the height of the particle Q above the pole CD. Okay, so let's do this. For part C, we will consider the horizontal motion at first. So for the horizontal motion, the horizontal component of initial speed u horizontal, it is 20 cos 60 degree. So cos 60 degree, it's basically half. So that means this is 10 meter per second. So we know that S equals to Vt horizontally. So we need the total time taken to reach the point C from A. So T equals to S is 12 over 10. So that is 1.2. 12 over 10, it is basically 1.2 seconds. So we got the time taken for the particle Q to reach the pole, right? Now use this time to get the vertical displacement. Vertically, u vert, it is equals to the velocity, the overall velocity, it is 20. So 20 sine 60 degree, which is sine 60 is root 3 over 2, that is 10 square root of 3 meter per second. We got the vertical component of velocity. Now consider the vertical displacement. S equals to ut plus half of at squared. So we are taking upward as positive. Okay, so displacement, vertical displacement would be 10 square root of 3 times 1.2 ut minus half of g times t squared, that is 1.2 squared. So the vertical displacement, it is 10 square root of 3 times 1.2, that is ut minus half of 9.8 times t squared, 1.2 squared. So that would give you 13.72860.969, that much meter. So when the particle Q is passing over the pole, it is at a height of 13.72 something, that much meter above the ground, since it is positive. So the question has asked find the height of Q above D. So above D we have to find out how much high it is going through, right? So height above D, above the pole, that is D. Height above D is the vertical displacement, that is 13.728 ... minus the height of the pole CD, which is 5 meter. So you will get a height, it is 8.72860.969.1, that much meter. So we can say up to 3 significant figures. This is 8.73 meter. 8.73 meter. Perfect. So the height above D, it is 8.73 meter, and that's the answer for part C from question number 5. Fine.